Hi, everyone. Welcome back to the asynchronous lectures for COM 372. I wanted to take a moment. This will be a short lecture, probably no more than 5 minutes, to talk about scan lines. Scan lines, frames per second, all of the different choices that you have in your camera and why they're there, what they mean, how they're used, how they evolved into this configuration that we now see. So at the beginning of the media era, or the film media era, film was ontologically a single photograph done on a medium using a chemical process that recorded light levels, was black and white, but it was a pretty accurate recording of life as it existed in that moment. So a photograph was a full plate taken in a fraction of a second, reflecting the lived moment that was recorded. Now, when television technology was invented, they could not figure out a way to transmit over television transmitters entire shots that could be put into a sequence that, with the use of a closed shutter, would create persistence of vision. So if you're at all confused about this, I'd like to be able to draw on a board, but I don't have a chalkboard with me right now. But let's think of the film strip as we know it, right? Film strip is either 16 millimeter, 35 millimeter, 70 millimeter. Across. That number refers to how wide the film strip is. So when I was a young film student undergraduate, I was working in 8 millimeter film. But 8 millimeter film and 70 millimeter film, you know, what Tarantino shot, what Tarantino shot Once Upon a Time in Hollywood on, the 70 millimeter film stock. You know, ontologically, they're not very different, right? I mean, 8 millimeter film, 70 millimeter film, the only difference is the size of the medium, but the medium is essentially the same thing, right? And what happens is you take an individual photograph and you expose that photograph, you put light through it, you shine that image onto a wall, and we see that still image. And if you then go for a fraction of a second to an empty image, a blank space at a rate of 18, 24, whatever, something above this minimum number, you create what's called persistence of vision. And the human brain sees the projection of still images one after another with very slight change between each image, you know, at a rate of 1/18 of a second between each image. The human brain can analyze that and interpret that as moving, right? So we all know it's a series of still photographs. When you place one next to the other, they create, through the persistence of vision, a sense of movement where there really isn't any. The key is the photograph and the empty space, and the photograph and the empty space for an hour and a half, right? It has to be one and the other. Without the empty space, the photographs would all mesh together and we wouldn't be able to make anything out of it, right? We have to have that moment where the screen goes dark for our brain to be able to process those images, and our brains process very quickly, but our brain processes those images as movement if it has that exact relationship. Light and dark, moving through space or through time at an exact rate. Okay, so television couldn't figure that out. The television engineers could not figure out how to get an entire image on your TV in the fraction of a second and then have your TV go dark for a fraction of a second and then have another image pop up at that same way that film works. But these guys were geniuses, right? The people that invented television, and it was, it was invented in a lot of different places around the world. A lot of people claim credit for it, but it seemed to have been happening simultaneously in a lot of different laboratories around the world. But what they figured out was they could send 1 pixel at a time. And if they sent the 1 pixel at a time, they could color in an image at the speed of light, basically. So they could go from the first pixel to the last pixel in such a fast period of time that they could draw an image 1 pixel at a time. But what they couldn't do is they couldn't figure out the blank space between drawing this image and then drawing the next. They couldn't figure out a way to make the pixel stop, go blank, come back. You know, once the light was lit, it stayed lit for a moment. So what they did instead is they interlaced the lines. And so when you see on your camera the option to go P or I, progressive or interlaced, progressive is the film analog approach where you draw the entire image at once, progressive scan. Interlaced, however, is from television engineering, the thing that brought us broadcasting. That, you know, we started with black and white in the 1940s, we went to color later, and then we went to HD, all that stuff. But what they did is they drew different lines, and they would draw lines 1 through 3, 1, 3, 5, 7, all the way down to 480. And then they would come back and they would draw the other lines on this side. And so by drawing all of the odd lines first, and then all of the even, what they discovered, and it's an amazing discovery, is that they achieved persistence of vision. And so what happens in an interlaced image is you never have the entire image up on the screen at any time. It's never there. What you have instead is you have those lines that are drawn, our brains interpret them. The next set of lines are drawn, our brains interpret that. And then that individual pixel at the very top corner starts drawing again from pixel 1, you know, horizontally square 1. So it's an amazing feat of engineering, and it tricks the human brain into seeing persistence of vision and seeing images in the same way that it would. The film engineers discovered that we could see image blank. By doing every other line, we have the same effect, and we see motion. And so that's what's being discussed. When you talk about frames per second, you're talking more about a filmed kind of reality, how many frames per second. Progressive versus interlaced, you're talking about a whole image versus the half image that's interlaced together. And when we talk about HD or 4K or SD, we're talking here about scan lines. How many scan lines are used to create this image? So an old television image used 480 scan lines. And that's why if you were to watch a television show from the, say, 1950s on a current 4K monitor, that image is a tiny box in the 4K box, because instead of being 4,000 lines across the screen, you know, counting from the top to the bottom, 4,000 horizontal lines, this was only 480. So it's essentially 1/10 of the information on the horizontal axis, and it's about 1/8 the information on the vertical axis. Wait, no, sorry, switch that around. 1/10 on the vertical, 1/8 on the horizontal. And so that progressively more detailed image comes from that, where we're sending out many more lines and much longer lines of information, and still interlacing them in the way that television always has. So that's the progressive versus interlaced debate that you have when you set your camera up for the first time. So if you decide to shoot 24p, you're shooting 24 frames a second, progressive, where every single image is recorded like a still photograph. If you shoot 60i, you're shooting in the television standard, in which you do 30 frames of 30 lines, 30 lines per second of the odd lines, and then 30 lines per second of the even lines, and the editing system is interlacing them together into a movie. And then drop frame is something that's not so important anymore. But if you're wondering why can't I choose 30 frames a second? Why do I have to choose 29.967? Where's that extra information? Why isn't it rounded up to even? That was because television engineers in the 1950s, 60s, and 70s needed to record and send extra information inside the broadcast. And so they would drop a couple frames at, every minute, every hour. They would drop some frames and they would send that information along that same path, but after they had already sent the video image. So drop frame is where one frame is dropped so that other information could be sent. And that's why our cameras don't read 24 exactly. They read 23.9 or 59.9. It has to do with that old television engineering standard. So that's what frames per second is about. That's what P versus I is about. And those are the choices that you get to make. But fortunately, Adobe understands all of that, and it can make a digital media project almost no matter where you set your camera. It can output to something that works on YouTube, works in digital media, and works at film festivals. All right, see you in the next lecture.